Hi everyone, my name is Moataz Hassan and it's a pleasure having you to talk about my research project on software-defined networks and security risks. This presentation is part of the capstone subject ITC 571 Emerging Technology and Innovation. The purpose of this presentation is to discuss my research project, which is based on reviewing a number of sources including books, general articles and other resources. I have also conducted basic installation and testing for a number of SDN controllers in a virtual environment. For more details, please visit my blog at cybersec.com.au. So, a quick overview of this presentation. We start by looking at the basic concepts in SDN. Then we look at the driving factors which have led to rethink approaches to network architecture, followed by touching on the basic concepts of information security. Then we discuss some of the security concerns related to SDN, which I have noted through my research. And finally, we look at what we have learned from this research project and conclude this presentation by providing some suggestions for those who are interested in deploying SDN technology in their networks. So without any further delay, let's begin. To understand the basic concept of SDN, let's compare the architecture of traditional networks and SDN networks. Traditional network devices are typically consist of the data plane, which is the hardware responsible for forwarding packets. Then we have the control plane, which provide the intelligence, such as selecting the route and setting priorities and policies. Also, in traditional networks, each device is individually managed. Now let's have a look at the SDN architecture. The basic idea of SDN is to take out the intelligence from the network devices and combine it together. So two concepts we can take out from this. The first concept is the separation between the control and data plane. The second concept is the centralization of the control plane. This will become relevant when we start to discuss the security concerns in SDN. Now let's have a look at the driving factors of SDN. We can look at this from two sides: issues related to traditional networks and potential benefits of SDN. Let's first talk about traditional networks issues. With new technologies, including cloud computing, Internet of Things, and big data, are increasing demands on the networks. And traditional networks were not designed to handle this large amount of data. Even with the increased supply in processing power, Ethernet speed, wireless speed, and 4 and 5G technologies, traditional networks struggle to deal with different types of protocols such as video traffics, voice over IP, and web traffics. The larger the network, the more complex it becomes to manage. As we mentioned before, that in traditional networks, each device is individually managed, which increases the chance to make mistakes in the configuration. Traditional networks also referred to as vendor dependency, which is basically mean that you typically have to depend on one vendor when purchasing network devices, so you get the full benefit of these devices. Now let's have a look at some of the potential benefits of SDN. As we seen in the previous slide, the centralization of the control plane provides a global view of the network, as well as centralized point to manage the entire network. This also minimizes errors and provide consistency when configuring rules on the network devices. And last but not least, SDN claimed to reduce cost by not required to depend on single vendor, like what we seen in traditional networks. Also, the cost of network devices will be less after they remove the intelligence from these devices. There are 2 points that I would like to comment on here. First, the cost reduction, which is claimed to be one of the benefits of deploying SDN, is based on the idea that once the control plane is removed from the devices, it will cost less. In other words, if we typically buy a Cisco device that used to cost $15,000, it might cost $10,000 after they remove the iOS and the application. However, we also need to consider that these dummy devices won't work without a controller. So you might think that you have saved $10,000 or $20,000, But what about the cost of the controller that will manage these devices? The second point that I would like to comment on is I don't really see that SDN will eliminate vendor dependency. Again, for those who prefer to use something like EIGRP, which is Cisco proprietary routing protocol, they have to use Cisco products. Last thing I want to mention that organizations typically want reliable vendor to provide support and constant update, unlike when using free or open source products which typically have minimum or no support. Enough on that, and let's look at the basics of information security. There are many elements of information security, but we're only going to discuss the main three elements known as the CIA triad, which is confidentiality, integrity, and availability. Confidentiality ensures that sensitive or private information are not disclosed to unauthorized person or process. Integrity is to prevent unauthorized modification or destruction of information accidentally or maliciously. And availability is basically the state in which the system resources are available when required by authorized user or system. The main approach that is used to maintain information security called defense in depth, and some called it the onion layers approach. The effectiveness of this approach relies on presenting number of challenges that typically must be compromised in sequence before the attacker can compromise the system. In the nutshell, breaking to one layer will lead to another. Defense in depth can be used to detect malicious activities as well as to provide early warning to system administrators. So why are we talking about this here? We're looking at the concept of centralization in SDN architecture. It appears that SDN is shifting away from the layered architecture and moving to the centralized architecture, making it less secure. In the next couple of slides, we are going to discuss some of the potential security issues with SDN. I would like to start this section with a couple of quotes which I have cited through my research. The first one says, "There is no such a thing as 100% secure system and there is no silver bullet." That is true. Any system can be compromised, even the very best. It is only a matter of time. But does this mean that we leave the doors open? Absolutely not. Which led me to the second quote that says, "Security is a process, not a product." So for example, when using an antivirus, we shouldn't expect it will completely protect the system from getting infected, but it will protect it from some viruses. Therefore, we need to have another layers of security to stop viruses from getting into the system. The same principle applies for any security system such as firewalls or intrusion detection or prevention systems. These systems provide a layer of security that help in defend, detect, and deter malicious activities. However, the more security layers we have, the less chance the system can be compromised. There are too much to cover in this section, but I will only cover the main points. So the first thing we will look at is the separation of the data plane and control plane. The separation concept has created more attack surfaces that can be targeted by hackers. By looking at a simple diagram for a network utilizing SDN, we can identify 6 potential points of attacks. Attacks on the data plane devices. Attacks on the links between data plane devices. Attacks on the control plane. Attacks on the link between the controller and data plane. Attacks on links between controllers. And attacks on the application, which is typically built directly on the controller. Some might argue that some of these attacks are also applicable on traditional networks. That is actually true, but we can also see that SDN have introduced new attack surfaces by creating new links that introduce new security challenges, which were not present in traditional networks. OpenFlow is the communication protocol between data plane and control plane. It started very good by forcing TLS in version 1.0, but later it started to head backwards by using TCP and having TLS as an optional. In fact, most of the switches does not support TLS. This also applies to some controllers which either have TLS as an option or doesn't support it at all. In other words, the communication between these devices is not secure and can be easily compromised. Centralization. There are a number of security concerns mainly related to the centralization concept. Centralized data is a big target for attackers. We already seen the number of attacks on cloud services and servers that hold large and sensitive data. Looking back when we talked about defense in depth, where we have number of security layers, in SDN architecture, all network devices will be connected and managed by a centralized controller, that is switches, routers, firewalls, intrusion detection and prevention system. So as Robert Hendon says, why take over the host when you can take over the network? We need to think, if the controller gets compromised, not only the dynamic data become affected, but also static data can be compromised and all nodes on the network will become defenseless. Also, as well as being a centralized point to control multiple devices, it is a single point of failure that will impact on the entire network. And the last thing I want to mention here, that number of researchers have proven the vulnerability of many controllers to number of attacks such as denial of service and malformed packet attacks. SDN is currently in the peak of inflated expectation in the hype cycle and remains as ongoing work with many challenges ahead, so it might be a while before we see the full potentials of it. After this research, I have came up with 2 suggestions for those who are considering to deploy SDN into their networks. The first suggestion is to only apply the technology to a part of the network. For example, in the hierarchy internetworking model, you might apply SDN technology to the core or distribution or the access layer only, but not for the entire network. The second suggestion is to only connect devices such as routers and switches to the SDN controller, while keeping network security devices such as firewall and intrusion detection and prevention are separate from the SDN controller. That way, you have something to fall back on and to alert network administrators if the controller becomes compromised. At the end, I would like to say that not every technology suits everyone, and IT professionals should make their recommendations based on relevant case studies and critical thinking, and not just by following technology market trends. I hope the discussion here can encourage security researchers to develop more and better security functions for SDN. And finally, I hope this has been informative and thank you for watching.